So minors and cofactors. So now in this minors and cofactors, what we are going to learn, see here there are two different terms, minors and cofactors. So first we will learn how to find the minors and cofactors for each matrix element, and then finally we will learn how to find the minors and cofactors for the entire matrix. So for minors and cofactors of the matrix element, so we have a matrix A which is A, B, C, D, E, F, G, H, I. And if you want to find the matrix minor of this element, which is the first element, that is A, what you have to do is you have to delete this row, you have to delete this column, and whatever is left you need to take the determinant of that. That's it. So minor of A, if you want to find, so delete the row containing A, delete the column containing A, what is left? E, F, H, I. So I have found the determinant of A, determinant of this part, which is EI minus HF. Now minor of B will be what? Delete the row containing B, delete the column containing B, whatever is left, DF, GI. So here I will be finding the determinant of DF, GI, which is DI minus GF. Now similarly, what is the minor of C? Minor of C will be delete the row of C, delete the row which is containing C, delete the column which is containing C, what is left? DEGH. So here I will be writing DEGH and find the determinant of this, which is DH minus EG. Similarly for I, if you want to find the minor, delete the row containing I, delete the column containing I, what is left? ABDE. So here I have written ABDE and get the determinant of this, which is AE minus BD. Clear? Now cofactor. We have the same matrix again, A, B, C, D, E, F, G, H, I. If I want to find the cofactor of A, then simply I need to multiply with this factor with the minor of that A. Okay, so minus 1 whole to the power of I plus J. I plus J actually indicates the row and the column. Okay, so I indicates the ith row and J indicates the jth column. So these elements you can write in this manner as well. So this is my first row first column, first row second column, first row third column, second row first column, second row second column, second row third column, third row first column, third row second column, third row third column. So if you add all these, that is 1 plus 1 is what? 2. So 1 minus 1 to the power of 2 is what? Even. So this will be plus. So of course this will be plus. So here we have odd, so here we'll be having negative sign. Here we have even, so here we'll be having a positive sign. And this sign convention, of course, it's simple, very childish thing. So if you want to find the cofactor of A, that means if you want to find the cofactor of A, first find the minor of this and then you multiply with this factor. So minus 1 whole to the power of 1 plus 1. Why 1 plus 1? Because you know that A is located at this location, which is 1 plus 1. I is 1, J is 1. So that is why it is 1 plus 1. 1 plus 1 is what? 2. Minus 1 whole to the power of 2 is what? It's 1. So which is even. So there will be no change in sign. Simply you need to multiply with the determinant, which is this. Now let's see an example out here. If you want to, for this particular matrix, if you want to find the cofactor of 1, what is that? Delete the row containing 1, delete the row containing, delete the column containing this one, and what is left? 5, 6, 1, 2. So find the determinant of this. Now what will be the sign for this? Here it will be positive. Why? Because you know that here we have plus, then minus, plus, minus, plus, minus, plus, minus, plus, and so on. So here the sign is plus, so that is why it is plus. And hence the value for this cofactor, you will get this value as 4. Similarly, once we have calculated this minor and cofactor for elements, then you want to find the minor and cofactor of matrix. So minor of this, let's say we have a matrix this, and if you want to find the minor of this matrix, then what you have to do, you have to put the minor values of all these elements. That means here what I have written is M11, M12, M13, all these are minor values. So M11 is the minor of 1, M12 is the minor of 2, M13 is the minor of 3, and so on. And how to calculate this minor of 1, minor of 2, minor of 3, I have already taught. So if you calculate the minor of 1, so that will be what? Determinant of 5, 6, 1, 2, which is 5 2s are 10 minus 6 into 1, 6. So 10 minus 6 is 4. Determinant of our minor of 2 is what? Minor of 2 will be 4 into 2, 8 minus 0, which is 8, and so on. You need to fill all these elements. So you'll get the value of minor. Once you have got the value of minor, then use this sign convention, that is plus minus for interchanging the sign. So once we have calculated this, so here it will be positive, so keep it as it is. Here it should be negative, so I have introduced negative sign. Here it should be positive, so positive kept it is. Here we have negative, so introduce negative sign. Here positive, so positive kept. Here negative, so introduce negative sign. Here positive, so kept positive sign. This was already minus 3, so there is no change in the sign. Here negative, so negative of minus 6 is 6. And here we have positive, so minus 3, no change. Okay, so like this we have to calculate the cofactor. Now one important term which is frequently being asked these days is the order of the highest order minor for this. This seems to be a very complicated statement, but forget it. It has nothing to do with anything else. Simply remember this statement as it is. That is, the order of the highest order minor of A m cross n is nothing but minimum of this m and n. Okay, if it is a non-square or rectangular matrix. Now if it is a square matrix, that will be simply n, but if it is a rectangular matrix of order m cross n, then it will be minimum of this. Okay, so let's say we have an example out here. So A, we have these elements, that is 1 2 3 4 5 6 7 8 10 11 12 18 and so on. So this 3 4. So order of the highest order minor, that is order of the highest order minor is what? Minimum of this, that is 3 and 4. What is the minimum of 3 and 4? Which is 3. So we can say that the order of the highest order minor for this matrix is 3. Similarly, if I ask you, this is a square matrix of order 2 cross 2, what is the order of highest order minor for this matrix? You will simply say it is 2. Okay, so this was an extra add-on which was given to you. Generally it is not found in textbooks, but in exams they generally ask all these utpita type of questions. See you in the next lecture. Till then, bye.